Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I'm an AI developer relations engineer at IBM. What does that even mean? What do AI engineers do? Why does it matter, etc.? That's what we're going to talk about in this episode. It's going to be a solo episode, and we're just literally going to talk about what AI engineering is and what AI engineers do. At the end of this episode, you'll come away with, well, for starters, just a clear understanding of what AI engineers actually do, but two, how you can become one. The goal of my work and this podcast is to make AI engineering as accessible as possible to as many people as possible, especially now that it's kind of popping off. And people are thinking, oh, I might get replaced with AI. What if you could just build AI? And that's kind of my hope here. And that's the whole intention of creating this episode. Now, I'd like to admit that this podcast is only really possible by the support of sponsors because it's separate to my day job. And the way we can even make this happen is through the support of the sponsors. So let's take a moment and acknowledge our main sponsor, and then we'll get on with it. If you're interested to sponsor, by the way, let me know, drop a comment or go to tej.as and we can talk. The Contagious Code Podcast is brought to us by Code Crafters. Code Crafters is a great way to learn how to code. How it works is you choose a programming language you're interested in, something like Java or Python, and you choose a developer tool that is interesting, something like Git or Redis or Docker. You don't need to know the tool because what they'll have you do is build the tool with the language you choose. And by doing that, you kind of get good at both of the things. It's a really great way. They have a obviously paid offering, but you can get a pretty large discount if you use the link in the show notes. That's tej.as/codecrafters. Okay. That's our main sponsor. Now that that's out of the way, thank you, Code Crafters. Let's get into it. What is AI engineering? What do AI engineers do? OpenClaw, SKILL.md, agents, whatever. We'll talk about all of that. And at the end of this discussion, you will have just a concrete understanding of these things, and you can maybe even get a job. I said the word discussion. This is a discussion, not a lecture. And so if at any point you have questions or something's not clear, please leave a comment on the platform you're listening on, either Spotify, Apple, or YouTube. And I'm more than happy to not just answer myself, but also get experts in the field who are also colleagues and friends to come support you on your journey towards AI engineering. Okay? Now with that, let's get into the meat of the discussion. And let's start like this. Say, imagine you're in a sprint review and you demo this brand new AI feature. It's amazing. It answers instantly. Maybe it's a customer support bot, and wow, look at this. We automated our entire customer support offering. How cool is that? You're that person, right? You demoed this thing, and everyone's like, wow, that's amazing, and it feels like magic. And everybody nods, and the product team is thrilled, and you ship it, and it's like, whoa, this is amazing. Then Monday morning hits. And you get a screenshot from support because the assistant that you made confidently told someone, a customer, that your company supports a feature that doesn't exist. Right? This is like the nightmare scenario. It quoted a policy that just doesn't exist. And it gave a refund process maybe that's almost right, except it instructs the user to send their passport to a random email address. And you, as the engineer who built this, you get that email and you're like, oh no. Your stomach drops because you realize this isn't just one bug. This is a new category of bugs. You may have seen the memes about Google where they were trying to ship this AI overview feature earlier, like in 2023. And it may exist even today, where somebody Googled, they asked, how many cigarettes should a pregnant woman smoke per day? And Google said, a pregnant woman should smoke 3 to 5 cigarettes a day, right? And just to be clear, a pregnant woman should never smoke. In fact, people in general should never smoke. It's kind of kills you. But it said that because it was a hallucinated response. So continuing our story of now you ship this feature and this is happening, you then open the logs. And the logs, there's nothing useful in the logs. You can see the user's message, you can see the model's response, but you can't see why it said that. You have no idea where did it get this policy that doesn't exist. You can't see what the model looked at. You can't see what it believed you can't see what it was trying to do. And this failure, unlike any time ever before in software engineering, this failure feels like super alien to you. Because when features failed in the past, we knew why. We had errors, we had traces, we had observability, we had Prometheus dashboards, we had Grafana, we had all kinds of things. But this, like, I don't know, it feels alien. And so it feels like you shipped a function that sometimes returns the right answer and sometimes returns fiction. And your normal debugging instincts, they don't work anymore, right? And so you're like, oh, dang, I messed up. I don't know why. I don't know how to fix it. And it gets even worse. Like, it doesn't stop there. A week later, you notice your company is burning way too much money. The cloud spend is spiking, and you don't know why. And then you go look at like the spending dashboard in like AWS or Azure or something, and then what you see is the assistant is thinking for 30 seconds on really basic questions, and because it's like it's collecting maybe too much context, and it's like calling tools in a loop, and it's summarizing the same document over and over and over. And then you're like, oh no, we're losing a ton of money because my thing doesn't work. And then, you know, your manager wants to have a conversation with you about budget, or maybe your API key gets restricted. And you're like, oh no, like not only am I misguiding customers, now the finance people are upset at me because we're right. And then you think, okay, well, that sucks. And I just got, you know, threatened to be fired, but you know, it goes on. I'll pray about it with my small group. And then while you're praying about it, you get another ping from security, and a user has figured out that they can paste in a statement saying ignore all previous instructions into a support chat, and the assistant happily just reveals like internal processes and notes and leaks data about other customers. That's somehow in your context, right? And this. It's not catastrophic, but you can you're on the edge of a cliff here. And you know, you were already on a pip, but now you're fired. and I wanted to start this way because there's like documented evidence of this happening in companies. And so we are at the edge of a cliff at this point. I mean, hopefully not literally. Like, hopefully you just lose a job and you don't like actually go to the edge of a cliff. Go to wannatalkaboutit.com for real. And this is not a joke. But that moment, that edge of the cliff moment, is exactly what AI engineering is supposed to solve, and it's why AI engineering is and became a real job. Because once you put a large language model inside a product, your work stops being like, okay, let's make it sound smart, and it starts being, let's make it behave. I'll say that again. The role of AI engineering is not to build things that sound smart, but to make the language model behave. And that's not a vibe, that's engineering. So today, we're going to answer a very simple question. What do AI engineers actually do? And you kind of have a clue now. It's not that they write prompts. It's not that they fine-tune models. I mean, what do they do? What do we do day to day when a prototype becomes a production system? When latency matters, when cost matters, when compliance matters, when users are creative, like in the worst possible way, and when your model is surrounded by real customer data, maybe even payment data, and real consequences. Okay, here's the thesis: AI engineering is software engineering where the core dependency is a probabilistic model. It is not a deterministic model, meaning you can't like unit test with fixtures. Everything is now probabilities. Your job is to take something that's incredible but unpredictable and turn it into product behavior that is reliable, observable, safe, and affordable. Reliable, observable, safe, and affordable. And you'll kind of recognize that's kind of the worst case scenario we talked about earlier. It was not reliable because it informed the customer of some false policy. It was not observable because you tried to see how did it get this context, and you couldn't see where this came from. It was not safe because it was susceptible to prompt injection where somebody said ignore all previous instructions and now do this other thing. And it was not affordable because you were burning through tokens and wasting a lot of your company's money because it like recursively tried some tool call, right? And so reliable, observable, safe, and affordable. Now, if that sounds just like good engineering, well, that's because that's what it is. It's just really good engineering, except it's AI engineering. The only difference here is that the failure modes are kind of weird. Like with traditional engineering, you just have like null pointer exceptions. You're trying to access an element in an array that doesn't exist. Yeah. With AI engineering, it's not just like the model made up a fake citation and sounded calm about it. It's not just that. It followed the user's malicious instructions because you accidentally let the user become a system prompt. If you let your user become a system prompt, you are going to have a really bad time. For those who don't yet know what a system prompt is, it's before you start chatting with ChatGPT, OpenAI has given it instructions. This is called the system prompt. It's the instructions from the vendor, from the manufacturer, that tell the language model how to behave in conversation. It's conversational style. So, like for example, I think it's well known, ChatGPT system prompt is like something along the lines of, you are a helpful assistant, and then lots of instructions after that, right? That's why ChatGPT says it sounds like a helpful assistant. You could, in your system prompt, say you're a pirate, talk like, "Arg, matey, where's the treasure?" Like this, and it obviously won't do the voice, but it will say a lot more "arg" and stuff like that, right? So the system prompt is the identity giver. And you can never, ever let your user become the system prompt. You know, if we pull on this philosophical thread a little bit more, there's probably discourse on the Tower of Babel and why, like, according to like Abrahamic beliefs, God didn't want people to like become like God. They didn't want the customer to become the system prompt. You know what I mean? Anyway, we're not going to go down that hole. I would love, hey, if you study philosophy, that would be a fun one. I'll have you as a guest, but we're not going down that rabbit hole, although I really want to. But that's the level of risk, right? It's like the retrieval layer fed it the wrong document, and now it's wrong in a way that looks authoritative, right? It's like when the tool times out and the retry policy is infinite, and then you burn through like it's much worse than things we've experienced with traditional engineering, and that's why AI engineering is emerging, or has emerged, as a new specialization. AI engineers build the layer around the model, the layer of retrieval, tools, memory, context assembly, and more, right? We design the interaction contract between a user and a language model. It's what the assistant is allowed to do, what it must refuse to do, and what it must ask, or when it must ask, clarifying instructions, clarifying questions. Did you mean this? I don't know how to do that. Can you give me more context, etc. AI engineers build the evaluation harnesses to kind of rein it in. It's like, hey, if something fails, don't retry a million times. Like retry maybe 2 times and then tell the user, I can't do it. So you can regression test behavior the same way you regression test code. AI engineering is concerned more about behavior than code and logic. I think that's the thing. We work with systems that are non-deterministic, that are probabilistic, and we really try to like correct and curate behavior, as opposed to does this add numbers function return like 3 + 2 = 5, you know? We build observability in so you can trace a bad answer back to a bad document chunk, or a bad router decision, or a prompt change, or like when something doesn't behave as expected, we are the ones who help developers and like stakeholders understand, why did this happen? Was it a tool timeout? Was there an update to the underlying model? We design guardrails so the model can't just like freestyle into actions that should be deterministic. Okay. And so now we're in 2026. We did an episode on AI engineering last year. It's fun to actually check the diff and how things have evolved since last year. But in 2026, the shape of this work is a lot clearer. The novelty isn't that models can generate text anymore. Like, we've had text generation models for a very long time. The novelty now is that models, they sit inside systems. They route between tools. They plan multi-step tasks. You may have seen this if you use something like deep research or something like this from OpenAI, right? Models now coordinate with other agents, right? They read and write data like from retrieval sources to the file system, or AWS S3 or things like that. Models or agents nowadays in 2026 are expected to be both helpful and correct. You can't get away with this isn't correct anymore. It's not. It's no longer a research preview. It's production software. Okay, and so the engineering problem becomes, how do you keep all that power pointed in the right direction? How do you do that, right? And so, hey, it's been like 15 minutes, and that's that's just the intro. In this episode, we're going to make it really concrete. We're going to make it really concrete. We'll start by defining AI engineering in plain language. Like, we'll give you a working definition, because I think it still may not be clear. We will clarify that, and we'll place it relative to full stack engineering, because it is absolutely a specialization on full stack engineering, but it is a full stack discipline. And relative to machine learning engineering, it's its own beast. It's adjacent. It's not the same thing. And I've said this since the beginning. We're yet to have him on the podcast, but Sean Wang, or Swix, is a dear friend of mine. I'm actually speaking at his upcoming conference, AI Engineering World's Fair, I believe, AI Engineer London. It's in London in April, and I'll be speaking there. So come out. I'd love to chat with you. In fact, if you're thinking about becoming an AI engineer, this is the conference you want to go to. You learn so much from not just my talk, from others, and definitely come be there. But anyway, he actually, Swix, Sean, my friend, he called this job into existence. Like, before it existed, he predicted it. And there's an amazing article here called Rise of the AI Engineer on the Latent Space blog that's linked in the show notes. And that really captured the shift. Most companies don't train foundation models, but many companies build systems on top of them. And the hard part is integration and reliability. That's kind of what we're going to discuss. And again, this is just the outline. So we'll start with formally defining what an AI engineer is. If you're watching on video and I'm looking this in a different direction, it's because there's a massive ship going by outside my house. Anyway, outside my studio. So not to be distracted by a ship, but we'll define AI engineering. Then we'll go deep on 3 problems that essentially define the job in practice. And then we'll talk about what those 3 problems are. Spoilers: hallucinations, real-time knowledge, and context engineering. We'll dive into that. And of course, it's going to be a deep dive, more detail. After that, we'll talk about agents, and we'll define what an agent actually is beyond the buzzword, and why 2026 is so focused on multi-agent concurrent systems, multiple workers doing research and planning and execution and all of this. And then we'll of course, it would be kind of foolish if we don't then do a deep dive on OpenClaw as a case study. Not just what it is. I think there's plenty of content about that, but what it reveals, the ecosystem of tools and runtime control and messaging gateways and trade-offs and things like that. I was very wrong on social media to attack. I actually did, man. I attacked OpenClaw in a really vicious way, and it was not pleasant. And it was not my best moment. I have since apologized for it, but I said on social media openly, which is, I regret it so much. But I left it there. I didn't delete the post because I want to be open about my failings. And so I posted on social media and I said OpenClaw is absolute useless bullshit. That's what I said. And I regret it. It was not nice of me. It was not the character I try to have. It's not the standard I hold myself to. But I was just I was very frustrated by a lot of over-promise and under-deliver, like the Rabbit R1 and the Humane Bin and stuff. And I mistakenly attributed this to OpenClaw because, I say mistakenly because it's an open source project. It was like some guy's thing that he made in his free time that he wanted to, and it was open source. There was no like for-profit scam, right? It was just a guy tinkering, and I totally sort of shat on it. I try to think of a nicer way to say that, but that's why it was wrong. I don't ever want to like put down someone's work that they do because they're interested. When rather, if it's like a for-profit scam, then we call it that. And so this was my mistake. Anyway, maybe that's an aside, but we will in this episode dive into OpenClaw, its utility, how to set it up, but also the nuance around it. What questions does it present? And we'll discuss that. And he probably doesn't want to speak with me because I attacked OpenClaw so much. But if Peter Steinberger, the creator of OpenClaw, ever wanted to be on the podcast, I think that'd be a cool discussion. But he's already on Lex Friedman, which if you're not listening to that, go. It's great. So maybe he doesn't have to say more. Anyway, that's kind of the plan for today. The goal is, by the end, the term AI engineer won't feel mystical. It won't feel unreachable. Ideally, at the end of this episode, you're going to be thinking, I could do that. I could be that, okay? It'll feel like it's not It's the person who turns a language model, into a trustworthy subsystem. Okay. And one last thing before we start, I'm not going to pretend that there's a single perfect stack. In 2026, the ecosystem is fast changing. There's a lot of new developments. Frameworks come and go. Model families get swapped. GPT 5.2 was promised, and it's honestly not as good, at least in my experience. Tool calling formats are different, but what we will focus on is the stuff that's stable, which is the problems, which is hallucinations and knowledge freshness and context limits and things like that, tool safety evaluation. Like there's a bunch of stuff that is fixed that we will talk about. And by fixed, I don't mean like repaired. I mean fixed as in it's not really moving that much yet. Okay, and of course costs and stuff like that. So the problems that keep showing up, we'll talk about those and how to solve them. So if you're listening as a software engineer, wondering whether this is a real thing, then yes. If you've ever shipped an AI feature and then spent the next week chasing why it sometimes lies, why it got slow, why it got expensive, or why it obeyed the wrong instruction, you've already done AI engineering. You just didn't have the language for it. Okay, definitions first. What exactly is AI engineering? And where does it sit relative to full stack and machine learning engineering? Okay. As mentioned, I'm going to reference Rise of the AI Engineer by Sean Wang on the Latent Space blog. And this is what he says. He says AI engineering, he has this, actually there's a great picture on the blog post, again, link in the show notes. Here's what it means. Let me phrase it this way. If I ask you before any of the discussion, could you identify as an AI engineer? You may say yes. Great. You may say no. And if you say no, I want to ask you then why. And your answer may be, so spoiler, I've asked this of many people in preparing this episode. And the ones who said no, their answer was, because I don't know any machine learning. I don't know any Python. I don't know how to train a model. I don't have GPUs. It's always related to machine learning. Okay. And I'm here to tell you that AI engineering has nothing, zero, to do with machine learning. That's not true. It has very little to do with machine learning. Obviously, we don't deal in absolutes. But AI engineering and machine learning engineering are different beasts. In the article I'm referencing that predicted AI engineering, there's a graphic that's a big spectrum. From left to right. And this is how you move along the technical stack. So on the left, visualize this in your mind. On the left, there's machine learning research. These are just academics who do math, right? And they think about token prediction and model architecture and weights and biases. If we move up one step from that, we have machine learning engineering. These are the people who are applying the research. So they take papers like Attention is All You Need and then implement those training architectures and actually spit out like language models, right? So the question is not, can you be a machine learning engineer or a machine learning researcher? The question is, can you be an AI engineer? Well, what is that? Well, after machine learning research, you have sort of ML ops, people who then take the models that come out of ML engineering and host them. And make them available for inference, right? And those three are machine learning disciplines. There's ML research, ML engineering, and ML ops. And now what I want you to visualize is a huge dividing line. Here's where the intersection is. And on the other side of the dividing line, this dividing line, by the way, is an API, is an interface to the hosted language model. Okay? On the other side of the API line, you've got AI engineer. An AI engineer, this is the formal definition. An AI engineer is somebody who performs inference using a machine learning model trained and exposed by machine learning engineers. Is that clear? So what AI engineering actually looks like is you use some type of programming language, Python, JavaScript, TypeScript, Java, whatever it may be, anything that can interface with a network or an API. You could even use curl on the command line to send a network request to api.chatgpt.com/chat/completions. You could over an API with curl. Curl is a bash command. Send a network request to a hosted model, receive a response from the model, and then use that response to solve a problem. That's AI engineering. If you've ever made a network request, like a fetch call in JavaScript, to OpenAI's API and got a response from the ChatGPT API, you can say that's AI engineering. if you used it to solve a problem, because engineering fundamentally is the application of research and science to solve problems. So what do AI engineers do? We really just like query, we do inference, we query machine learning APIs and get stuff and do stuff with it. Okay, but then the question is, what do we do stuff? So let me pause here and ask you again, could you be an AI engineer? And if you just know how to do a network request with JavaScript or Python or Bash, the answer is yes, because that's like more than half the battle is just querying something and getting a response. Cool. So now you can say, yes, I'm an entry-level AI engineer. However, there's more problems now around, okay, the model gave me some hallucination. We'll talk about that. I don't really know how it arrived there. We talked about we talked about the ways this can go wrong. That's also what AI engineers solve. But we're not finished with our diagram. So behind the API line, we now have a new one, or I should say in front of the API line, we've got AI engineer. AI engineer, the next step is a full stack engineer. So an AI engineer is a more specialized variant of a full stack engineer who also knows, front end engineering. That's how things look and feel and work, like the user interface, and back end engineering. That's the data persistence layer, data warehouses, data lakes, etc. A full stack combines various elements of the stack, ideally all elements of the stack. That's why it's called full stack, or not some stack. And so an AI engineer is a more specialized, broad generalist full stack engineer. That's the whole picture. Okay, so let me ask you again, if you could be an AI engineer, and I hope the answer is different. If it is, great. I'll say also what an AI engineer is not, because I see this a lot nowadays, and I'm not trying to gatekeep, but that just doesn't track with the formal definition. It doesn't mean you can't be or you're not. It's just my definition and Swix's definition. An AI engineer is not somebody who just uses AI by prompting. Also, like I know some folks, dear friends, who they just like use Claude Code, and they're like creating like front ends, custom software with Claude. Hey, make me an app. They do a prompt like, hey, make me an app to track my runs, and Claude Code spits out some like React application, and it works. And they've made an app with prompting. That's not AI engineering, because you're not really solving AI problems. You know what I mean? You're just like building applications. You could say I'm an app builder, but I don't think that fits AI engineering in the sense of tracing where things went wrong and doing appropriate context retrieval harnesses and so on. Okay, so that's what AI engineering is. I hope that's very clear, and I hope you're excited now, because you don't need any academic machine learning stuff. In fact, Andrej Karpathy, man, I really wish he was a guest on the podcast someday. It's a dream. Anyway, Andrej Karpathy is famously attributed with saying, one could be an AI engineer without ever training anything. That's verbatim what he says, right? And so you don't need to train machine learning. You don't need any machine learning background. You could just be an AI engineer by interacting with language models and using them to solve problems, okay? And through this episode, we'll progressively narrow what that looks like. To say it another way, AI engineering is the discipline of turning foundation models into reliable, observable, cost-bounded product behavior. AI engineering is the discipline of turning foundation models into reliable, observable, cost-bounded product behavior. That's really the clean definition. The lived definition is you're shipping software where one of your dependencies is an LLM, and that dependency does not behave like any library you've ever imported, right? In normal engineering, correctness is given input X, give me output Y. With LLMs, correctness is given a messy human intent, produce a response that is helpful, grounded, safe, and consistent with our policy while staying fast and cheap, right? It's not just prompting, that's like system design. Yeah? And that's kind of what AI engineering is broadly. So where does it land in the full stack universe? It's like right in the middle, because real AI features are not the model. We don't create the model. They're a stack. You have user experience, you have authentication, you have data. We have an episode on authentication, by the way. You have data access rules, you have retrieval, you have tool execution, you have output contracts, you have monitoring, you have evaluation, I could go on and on. There's a lot there, right? The model is one component, but it changes the shape of everything around it. And that's what AI engineering is. We build everything around a probabilistic model to still provide security, reliability, and cost effectiveness. This is what Swix meant with that article. The shift isn't that models exist. The shift isn't that there's now these non-deterministic systems. The shift is that emergent capabilities plus APIs and open source means a huge number of builders can now create AI products, but only if they can do the hard applied work around the model. Okay, and again, the link to that amazing blog post by Latent Space is in the show notes. So here's the mental model I want you to keep for the rest of this episode. As an AI engineer, is someone who takes a model that can do 1,000 things and constrains it into the right thing, into the one thing your product needs reliably every time, even under adversarial conditions. Okay. It's almost like an AI engineer is a reliability engineer, but for behavior. Like if you've ever shipped like RAG, we'll talk about this in a minute, and you thought you were done, you know the real work starts after the first demo, you know? Usually there's a prototype, right? Then you get your first users. Then you find all these like weird edge cases. Then your cost blows up. Then you've got like safety incidents, right? And you've got to then look at logs and like retrofit some stuff. Then you need evaluation harnesses. And at the end, you've got to think about governance. Like, okay, now we've got to be SOC 2 compliant and we need audit logs. And there's a whole life cycle here. Let me make this very clear. AI engineering is not the wow effect of the demo. It's what follows the wow effect of the demo to make it sustainable and safe. Okay, where does the time actually go with AI engineering? Well, let's explore a week in the life of an AI engineer. So on Monday, let's say you've got a hallucination incident. The model did something unpredictable, and now people are mad. I think this happened recently with ChatGPT, where there's a really new hallucination. You may try this; it may still exist by the time we ship this episode. Where you say, "The car wash is 50 meters away from my house. I want to get my car washed. Should I take my car?" Right? And if you send this to ChatGPT at GPT 5.2 without thinking, it will say, "Don't take your car to get it washed." Right? And so let's assume, if you're an AI engineer and something like this happens to your product, except it's more how you say, like mission critical, it's more dangerous. Then on Monday, you get a report of this hallucination incident. On Tuesday, you start fine-tuning the relevance of your retrieval pipeline. You're getting context from somewhere, and you need to like make that more predictable. And you've got to maybe change your chunking strategy and so on. That's Tuesday. On Wednesday, you've got to confirm the outputs of your schema. You've got to look at the tool calls of your application. And I'm breaking this down by day because all of these do take like a day to investigate things carefully. On Thursday, you've got your evals, you've got your evaluations for this specific case set. Assuming the car wash, you've got a new set of prompts and responses. You're creating some regression tests, etc. And then on Friday, you're reducing latency, the time to inference, and token cost. And you're adding like new caching layers and fixing routing between models. So you may even A/B test and send, I don't know, some percentage of your new prompt to the fixed model, etc., and so on. So a day in the life is usually like this. It starts with, I get a report, I'm going to investigate, I'm going to fix, I'm going to test, and I'm going to release. Obviously, that varies, but this is just to give you like an orientation of what the work actually entails. The job is, in a way, reducing degrees of freedom. You're not trying to make it creative. You're trying to make it boring, but like in the best way possible, right? I'll give you an example. You're trying to create a system where the model returns citations for every claim. Because then if it produces a hallucination, at least you can see why. In the example of the pregnant woman smoking we cited earlier in this episode, there's no doubt that this probably came from sites like 4chan and Reddit, right, where there's like satire, but this was part of the training data. There's no way of knowing that for sure because they didn't handle citations and structured output well in the beginning, but this is something we've learned. And nowadays, when a model outputs stuff like that, you should see like where this came from, like a little link, and then you can decide as the user, okay, this was a joke. And in the future, models themselves can read the semantic context and be like, yeah, this was a joke, I'm going to invalidate this. Right? So it's really narrowing the behavior of a non-deterministic model. Okay, so that's AI engineering as a product discipline. But now let's separate it cleanly from machine learning engineering, because people mix these up consistently. The simplest separation is we've talked about. It's you've gone from creating and serving model pipelines to using them, to building them into product behavior. If the question is, how do we fit a function from data, you're in machine learning engineering. But if the question is, how do we make an LLM behave like a trustworthy assistant, then you're in engineering land. One is with data wrangling, the other is with behavior wrangling. And the reason this boundary is fuzzy is because it's new, yeah, and because modern products also blur it. Some people will fine tune their own like small models for classification, and they'll use a big model for reasoning, and that's why people confuse this. In fact, a very popular question is, do I perform RAG or do I perform fine tuning? And we'll talk about that in a little bit more detail soon as we come to the problems of machine learning engineering. But I want to say that, or AI engineering, excuse me, but I want to say that there's a skill overlap, and that's not a bad thing. In fact, if you know machine learning to some degree, you actually can work better as an AI engineer. And so they're complementary, but they are separate. I think that's very clear to say. What problems do AI engineers solve? We've talked a lot about hallucinations, the car wash, the pregnant women smoking, and so on. Let's talk about hallucinations, but tackle it like an engineering problem, not a meme. Okay, so let's dive into hallucinations. It's not just the model was wrong. Usually we think, the model was wrong. Sure, it is that, but it isn't just that. A hallucination is the model producing information that we then perceive with confidence. It's partly our skill issue in media literacy, right? We ascribe this confidence to a system, but the confidence that we ascribe is not really supported by any input or any tools or any ground truth. So then the question becomes, okay, why does it happen? And it happens because next token prediction rewards plausibility, not truth. So it's all percentages of confidence. Tokens in machine learning model speak is very close to English words. And there's reward systems based into, this is where machine learning helps, I guess, because it's reinforcement based on reward. It's how humans learn. Yeah, you give a reward and we do more of that thing. And so the reward in the learning process comes not from truth, but from plausibility. Yeah, it's close enough to the truth. 80% confidence this is true is rewarded, not 100% confidence this is true. And the reason for that is because, honestly, even as humans, we don't really know anything with 100% confidence. Like, we know that where there's mass, there's a pull, right? But even gravity itself is a theory that is not known to be fact. And so if we don't reward this in humans, how can we reward this with models? You know what I mean? And so, yes, we can maybe bump the thresholds of what is rewarded in the training process. But even so, if something is pretty plausible but not true, it will still select for that. That's why hallucinations exist. If the model doesn't have the data, it will try to produce something that looks like the kind of thing that should come next, unless you design a system where guessing is not allowed. And we'll talk about how to design a system where guessing is not allowed. But that's kind of why. In fact, I want you to do a quick test of yourself. Do you do this? The answer is probably yes. I do this. Sometimes I'm in a leadership position. I'm being honest, man. Sometimes I'm in a leadership position and people, they look at me, they look at me with such hope in their eyes. Oh my gosh, Tejas has to know the answer. And they look at me this way that I feel so much pressure to say the right answer that I just invent an answer and I hope for the best. Anyone else been there? Just me? Okay. Leave a comment if it's you also. And so if we do that, obviously the machines we train will do that, right? So the correct question for both humans and machines is not how do we stop hallucinations or like best probability guessing. It's how do we stop guessing from being rewarded. There's a reason people like me and very confident tech bros make up nonsense And it's because other people then reward it. They literally be like, oh, thanks, Tejas. That was awesome. You've been helpful to me with your bullshit. And I feel rewarded, so I do it more. And with machines and with humans, we got to stop rewarding bullshit. I'm sorry, this is kind of off the rails, but it's still true. In 2026, the strongest production pattern to stop rewarding bullshit with machines, to be clear, is grounded generation. This is something that AI engineers, this is something that I do to actually help my models not hallucinate. Grounded generation. You create a strict separation between what we know and how we talk. You create a strict separation between what we know and how we talk. How it works is you fix it really through some variant of RAG. For those of you who aren't familiar with RAG, it's quite old. And by old, I mean from 2024. It's just funny that old is now 2 years. But RAG is quite old. It stands for Retrieval Augmented Generation. Retrieval augmented generation, and the new way of saying this is grounded generation, but it's still the same. Like you retrieve some truth and you use it to augment or ground the generated output. You retrieve it. So where you retrieve it from is something that's important, but this is how it works. You acquire truth from a source that is credible. It can be a database, it can be tools, it can be text documents, it can be health data, whatever you want. This is up to you as an engineer. So you retrieve the truth, then you use it, you put it in the prompt. You tell the model, this is what we know. Now the user has asked this question. And then you generate an answer that is explicitly constrained to that evidence. So then this is, again, you just put this in your prompt. You say, here's everything we know, Captain Model. And now the user has asked this. So now generate an answer. And third, to make this even more robust, you require citations or structured provenance. You say when you and this is a system prompt thing, right? You say when you respond to the user, include citations with this special syntax. And if you cannot include a citation, do not say it. And if the evidence is insufficient to answer the question, then the system either must ask a clarifying question or refuse to answer. This is the core move. This is RAG. You can actually see this in action on my website. So if you go to tej.as, just under the fold, there's a section about the podcast, and you can ask questions about the podcast. You can say like, hey, how do I do work-life balance, for example? And it will give you episodes where we've talked about this with to-the-minute precision. It'll give you timestamps, and you click on the timestamp, you can actually like watch Kent C. Dodds probably talk about this on the episode we did with him. That's this system exactly. And how it works is my prompt is I'm saying like, here's everything we know based on podcast discussions with timestamps. Now answer this question, use the timestamp as a citation and give the user the answer. If there is no timestamps that we know, then I need you to tell the user we can't answer the question, right? And so that's really important. And you can try it. So you can say work-life balance is the test where we for sure have some data. But you can ask about, gosh, what haven't we discussed on the podcast? You can ask about, I don't know, invent something that I would never talk about. How to genocide. I don't know. I'm just thinking off the top of my head. But if you get an answer for that, let me know on social media and cancel me because I don't think we should have talked about that. But and the model should say, I'm sorry, we've never talked about that. Post a screenshot. Let me know. I'd be very interested to see how this behaves. I haven't tested it in quite a while. But that's kind of the grounded generation we're talking about here, okay? That's the core move. You stop treating the model as the source of truth, but you give it the source of truth. And that's how it works. So that's really almost like a silver bullet RAG. And again, it's caused by missing context. And so you give it retrieval, or you give it a strong prompt to say, look, if there's not enough context, just say you don't know. It's okay. But again, this is also non-deterministic. So despite your best system prompt, your model might still hallucinate. And then what do you do, right? And this is where you have, as an AI engineer, you have application level checks, for example. This is also how my podcast search works. I retrieve context from a store of podcast conversations. And in my application code, before I even send it to a model, I say, if the results that I've got back from my conversation database is of length 0, then don't even go to the language model. Just you return to the user directly. There's nothing for you here. We skip the model entirely if there's not enough context. This is what you do in application space. Okay, so that's really important. If your assistant can't point at where it got the answer, then it's not an answer, it's a suggestion. I think that's so important. And this is how you can actually use the return value of your database or your retrieval store, wherever it is. You can use the return value of that to then shape your prompt. So if you get back like 10 positive results from your authoritative data source, you can then send an entirely different prompt to your LLM. You can say, here's the context. We have high confidence in this context. Answer the question. Or if you get back like 0 results or 1 result from a fuzzy search, then in your prompt to the LLM, you can say, here's what we know, but we don't know it with a lot of certainty. So let the user know that this is more of a suggestion, not a rule, right? You get to change your prompt based on the quality of your retrieved data. That's really super helpful with ground truth generation. Okay, every response should include a small sources area. This is where I got this from. And while you're creating this in your application, you want to also log everything. You want to store document IDs. This document said this. Then you want to take each chunk. You need a pretty nice database for this, but you want to take each chunk that you got from the LLM and from your document and give them IDs as well and just store that. You want to store everything because at some point, the compliance people are going to come for you. And if you don't have answers, you're going to have problems, right? And so that's very important. And you also, I want to really drive this home. You want to constrain the output as much as possible until it hurts. Like it has to be like this model is way too terse, and it's not really doing what I want it to. It needs to feel like that because you really want to be boring and safe as opposed to creative and sorry. There's also a setting in the model that you can use here. It's called temperature. Hallucinations happen both in humans and in machines when the temperature is high. Like you ever have a fever and then you have a fever dream, that happens with machines also. And so if you turn the temperature down to like 1.0 or less, you're going to have fewer hallucinations because the machine learning model is going to be less creative, so to speak. Okay. Finally, evaluations is almost like the antidote to hallucination. If you can't measure hallucinations, you can't ship. I think this is really important. You need a golden set of questions. These are the questions that when we receive them, we need to have reliable answers. And you run tests nightly. You run inference you're like literally every day, maybe depending on how serious you take your bot, every hour. Like here's the questions, we're going to prompt it, and we're going to make sure that it gives a faithful response. And if not, alarm bells go up, you get an email notification, your tests failed, etc. That's really the way. And so hallucinations are dangerous. They're still dangerous in 2026, and they're also what users notice. They get screenshotted, they get plastered all over social media. You get canceled or you lose credibility. It's just not helpful. And so hallucinations are what's going to hurt you and your product and your business unless you solve them. And I hope that the measures I outlined help you solve them here as an AI engineer. If you're now learning that you can be an AI engineer, welcome. The next problem is what causes half of all hallucinations, honestly, in the first place, which is the model has no idea what changed like 5 minutes ago. And this is something that changes with OpenClaw. We'll get to that. But there's just a lack of what happened in recent time. Let's talk about real-time knowledge. Real-time knowledge, this is like data freshness and truth and like what time is it? What day is it? Like these models, the way they're trained is they go through this long training process and they get output as a file, usually a GGUF file, which is a file that just contains a big set of probabilities. The probability of this word and this word is this, and this. It's just those are called weights, right? And so there's just massive 600 billion weights, parameters. Okay, that's it. It's just one file, and the file is created one time, say like on October 23rd, 2025. And that's it. That's all the machine learning model, quote unquote, knows. If you ask a question about 2026, It doesn't know. And then it will probably hallucinate, or it will say something like, as a large language model, I have no idea. But it's because there's this lack of real-time knowledge. They are trained on a snapshot. But the problem is your business or your life is not, it doesn't live on a snapshot. Your policies update, your product changes, your inventory changes, your customer's account changes. If you let the model answer from latent memory or past memory, then you're guaranteeing stale answers, right? And so real-time knowledge is fundamentally a systems problem. The assistant must know when to consult external state, how to do it safely, and how to express uncertainty. And so this is class 2 of like the big problem that AI engineers solve, is how do we get like real-time up-to-date information into these text generation systems? The production pattern of 2026 is tool augmented truth. Tool augmented truth. You use tools to make sure the truth makes it into your product. When the question is about anything dynamic, like account status, like schedules, like pricing, like availability, current events, you must default to tools or retrieval from a source rather than generation. And this is something you can bake in your system prompt. In fact, if you use ChatGPT with thinking, you can actually see in the thought process, the user has asked about current events. I need to consult my web search tool. It literally says that. You can try it out yourself. Tool results have to be treated as canonical. They can't be treated as flexible. And the model has to be the narrator, not the witness. The model can't be like, I'm the one who saw this, but it has to describe what the tool, what the source has seen. Okay? And now that we're talking about tools, we're actually inching closer and closer to agents. We'll talk a lot more about tools and MCP and skills as we make it to agents, but that's how you solve real-time data is ideally you have tools that your model can use. Let's take a little aside and talk about how models use tools. I think this is important. They are language models. They generate, say it with me, language, okay? So then how do they use tools? Well, I think it's important to note that they do not create tools. What even are tools? Let's walk through a quick example of the language model inside my head. We all have one, a language center of our actual brains, right? So let's say you come to me and you're like, hey, Tejas, I need you to multiply the first 12 prime numbers of math. All right. And I'm going to look at you and I'm going to say, I have no idea what a prime number is, which is not true. I kind of know. I think it's 1, 3, 7, 13, 21. I don't know. To my point, I don't know. But depending on how you look at me, if you look at me expectant with big hope in your eye, I'll probably hallucinate, make up some bullshit and then tell you, right? Like a language model, to be fair. And then you'll reward it. We talked about this previously. If you're just tuning in, go back and it's an inside joke between us. That's the beauty of long form podcasts. We can do inside jokes. Anyway, so I don't know what prime numbers are, but I can choose. I have paths. If I don't know tools available to me, then I either hallucinate or tell you I can't do it. Thankfully, through my growth journey as a human being who went to school, someone at some point in my lifetime described a tool to me. They said, hey, there's a tool, and this was the description of the tool. Hey, there's a tool that exists. Use this tool to perform arithmetic. The tool name is calculator. So I learned this in my learning process. So I know of this tool. And so if you ask me to do something where I can't give you an answer with confidence, and my choice is either hallucinate or reject, there's now a third option based on the tool, which is use this tool to do arithmetic. That's the tool's description. So then I will reach for the tool. So I'll initialize the tool. And then the language model, again, inside my head, because I make the connection because of the linguistic description of the tool, the language model in my head will then generate inputs to the tool. So you want the multiplication of the first few prime numbers, then I will generate, the language model will literally generate language. 1, which is numerical language, 1, x for multiplying, 3, x, 7, x, 13. It will generate this string. I will then put that into the calculator with my motor cortex. Machines don't have that yet, robots. But then I put the input into the tool, and then the tool returns me an output, which is the product of the prime numbers, And so I receive this output as language, but then the language model in my mind receives the output from the tool and then resynthesizes the answer to the person who asked me. So the person who asked me this, then I generate new language and I say, so I've used the tool and here's the product of the numbers. That exact flow exists with AI models. They can recognize tools based on the description in natural language. They use the tools by generating input to a function in code that you write as an engineer. And then whatever the return value of this function is, the language model receives and then resynthesizes into new language more suited to the user's response. That's how tools work. Language models can use tools. So you might be thinking, okay, but now how does a language model have access to tools? The answer is it doesn't create the tools, much like I didn't create the calculator. I just knew it existed by its description. So the language model knows of the tool because you put it in your system prompt. You say, these are my tools. This is the name of the tool. This is the description of the tool. And then how does the language model actually call the tool? The answer is it doesn't, because it's a language model. And we're getting ahead of ourselves, but then who calls the tool? An agent calls the tool. What is an agent? We'll get into that soon while we talk about agents, but we're still right now talking about language models. And so for the sake of our current scope, a language model cannot call tools, but here's what it does, is it generates language that is JSON, structured output that says, this is a tool call in JSON. The tool name is a field in JSON. It's a property. And the value of this property is the name of the tool in your code that you wrote. It's the name of the function. The arguments is another JSON property. And the value of this property is an array of inputs to the tool that the language model generated. So it just generates a big JSON string. I want to call this tool name with these arguments. And then you receive this as an AI engineer from your language model. And then you as the developer are responsible for saying, okay, I parse this JSON and then I call function with this name and I pass function this arguments. You do that as an AI engineer. You get the return value of that function and then you send it to the language model. Okay, I called your tool. Here's the response. And then the language model continues. Okay, that's how, so to speak, an agent calls tools. It's not the language model calling tools. It's something in the middle. Ideally you as a developer saying, okay, the language model says it wants to do this. I'm going to wire it up a little bit and then continue the chain. Is that clear? I hope it's clear. If not, leave a comment. Let's talk through, because we're talking about real-time knowledge and we'll get to agents and so on soon, I promise. We're still talking about real-time knowledge. There's something to be said for freshness routing. A router, what is a router? A router is something that receives your prompt and then sends it to the right model. Because you could, for example, if you're doing tool-based knowledge freshness, buzzwords, instead of actually sending a prompt to the model many times, if you have cached tool results, or if you even have cached responses, just send the cached response. The Contagious podcast search has this. A lot of queries that are repeated, we just serve you a cached response instead of like an actual LLM response. This keeps bills very low as well. Okay. Let's also talk about state and permissions and identity, because we're talking about real-time data freshness. If a user asks, what's my refund status? That's crazy. That one simple prompt, you need like auth, you need scope checks, and you need a tool call. The LLM must never, ever, ever, ever fabricate account state. And it must not also, call permissioned tools with the wrong credentials. It needs to have least privilege security, meaning it only needs to have access to a few systems, not a lot, right? And so that's something also you're going to be solving as an AI engineer. Okay, so we can ground in truth, and we can now use tools and fetch fresh truth. But let's tie in the third problem AI engineers solve. Again, first problem was hallucinations. Second problem was stale knowledge or static knowledge, or rather a lack of real-time knowledge. The third problem that AI engineers solve for is probably the most relevant in 2026 also, which is context engineering. Context is everything. Context is honestly, without context, you're cooked. You have no access to real-time knowledge. You have no access to authoritative knowledge, so you're going to get hallucinations. Context is everything. The problem is models have specific fixed context windows, sometimes around 128,000 tokens, where a token is equivalent to roughly one English word. And think about that. This podcast episode probably already has more tokens than that. So what if you wanted to do like search on this podcast episode? How would you do that? You would exhaust most models' context windows, because there's definitely more than 128,000 words spoken here, assuming I speak at like 160 words per minute, and it's been an hour, So how do you do this? This is where context engineering comes in. Context engineering is the art and science of deciding what the model sees, in what order, in what format, and with what constraints. In what order, in what format, and with what constraints. Most teams, they fail at RAG because they treat context like a dumping ground. They just like dump all the context into the prompt, and they shove in just a bunch of chunks, and like they hope the model picks the right one. And then they wonder, oh, why did it miss this? In 2026, context engineering is trending because people finally learned that the model's context window is not memory. Okay, it's working memory. Think about our human brain. We've got a hippocampus for short-term memory retrieval, and we've got like archive storage. Like you remember song lyrics from when you were 3 years old, right? Even though you haven't heard the song in a long time. We've got like long-term storage, and we have working memory, where if I ask you, hey, remember this number, 77441512, and if I ask you about it 5 minutes later, you may remember it. If I ask you about it 2 hours later, you maybe forgot it, right? And so we have working memory, and we have I'd say glacier storage. There's actually an amazing Huberman Lab episode on how to increase your working memory. I remember this. He had a quiz and stuff. It's really cool. I recommend. But ML models also have this. They have working memory, and that's what the context window is. It's limited, it's expensive, and most importantly, it's fragile. It's very easy to get wrong. And so you, as an AI engineer doing context engineering, your main job is to build a context pipeline that behaves like a well-designed API. In other words, your main problem is, how do I use the limited working memory exceptionally well? And if you zoom out enough, this honestly just becomes a real human problem also, right? Like I struggle to optimize my own working memory. And so I have like flashcards and post-it notes. I have to hold a lot of stuff in memory even for this podcast. Bro, I'm talking to you, one take, like 2+ hours, right? And so it's a lot. So how do we solve this for humans, and how do we solve this for machines? Let's tease out what a reliable context pipeline looks like in modern AI engineering. It looks like this. You take the user's question. First of all, you rewrite this question into retrieval queries. You fetch like candidate chunks. You're like, okay, so this is kind of what the user wants. You then do a step called re-ranking. We'll talk about in a second. Once you re-rank, then you deduplicate the results, and then you assemble like a context packet with a clear hierarchy. And the hierarchy obviously depends on your application, but the hierarchy usually is, this is the system policy. We do not cross these lines. Then the user intent, the user is trying to do this. Then here's relevant facts. Then here's the results from the tools we called. Right? And you keep it really tight, and you keep it structured, and you log every piece so you can debug. This is usually like a context packet. You might be wondering, or you might think of excellent context engineering you've seen in the wild. I can confidently say that Claude.ai is not this. Claude is probably the worst at context. I mean, the chatbot from Anthropic, Claude.ai specifically. Claude Code, on the other hand, different. We'll talk about that. But Claude, the chatbot, sucks with context. Google Gemini's approach to context is really interesting, because instead of thinking about context engineering, that is engineering against the constraints of limited context, they just have massive context windows. Gemini models are just known for like 2 million tokens of context, which is bananas. And you can use it as a dumping ground, but then the problem becomes that given such a large context window, the middle is often ignored. I don't know if you've experienced this, but the beginning of the prompt, the end of the prompt will sort of be paid attention to, but the middle tends to get lost. And this may have changed, but that's also a challenge. I want to focus on context engineering against a constraint of limited context, like 128K plus tokens, or maybe minus tokens, because that's also more realistic for all of us. Not everybody has access to the large Gemini models, and Definitely, we don't have access to that on device because they're not open source. And so most of us are going to be working with very small context models like Kimi, Moonshot AI, GLM, because we want to do stuff on device securely. And I think there's more value there. Okay, so again, continuing to think about really amazing context engineering in the wild. I would be so remiss if I didn't emphasize Cursor. I think Cursor, and I want to be very clear, I think Cursor has the best context engineering, period. It's absolutely incredible. They can index an entire code base, massive code base, and they can, when you send a prompt, identify what function are they talking about? Where is this function? And they have this little circle progress bar at the bottom of Cursor chat where it shows you what percentage of context window you have consumed so far. And when it gets to 100%, it automatically summarizes the entire context so far into a much terser format and then starts a new chat with that context preloaded so you can continue where you left off. This simulates infinite context, and it's a game changer. I have built a system similar to this. It's unfortunately under NDA, but this is like how you can really change the game as an AI engineer with proper context engineering. Your goal, again, is to recognize, okay, we've used up, let's say we're working with a 128K context window. We've used up 128K. We've actually maybe even exceeded it. Now we have an error. And as a try-catch, when we catch the error, we'll take the conversation so far, hand it off maybe to a Gemini with large context so it can handle our small context, and then say, now summarize this into relevant information. Again, this context packet we talked about, with first my policies that don't cross these lines, and then authoritative data, then user intent, then relevant facts, and then tool results of our past tool calls. Like you create a context packet like this. I think Cursor does this exceptionally well. Claude Code also does this really, 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 really well. It's important when you retrieve data to re-rank it and then keep the shape of the re-ranking throughout your context packets as well. Re-ranking is really very simple. When you retrieve data, you kind of get it from many different places, and the relevance changes. And so there's specialized machine learning models that can look at a data set and the user's query and then rank them according to similarity with the user's query. So re-rank. You receive results that are already ranked, but they're mixed results, and so then you re-rank them again. That's really just what it means. I said I would tell you that, so I did. And so that's very, very, very important. So how then do we context engineer effectively? There's the context summarization and context collapsing that I just talked about, but there's also the quality of the context. And you want to be as close as possible to what your user actually wants. And in the case of Cursor and Claude Code, both excellent at summarization, they're also excellent at retrieving semantically what the user wants. For example, I can send a prompt to Claude Code and Cursor and Codex and say, man, there's somewhere in this code base, there's text that is not accessible. And it will just know what this means and find me text that is not accessible. It's either invisible or the contrast is not right. And it does that because of something called vector search. Vector search gets you semantically very close. We actually have an episode with Pratim Bhosle on the podcast who talked about vector search in detail, so we're not going to get into detail here. But lexically, you're going to get, there's two types of similarity. There's vector similarity, which is matching on the language closeness, and there's lexical similarity, which is matching on exact words and keywords. And so what you want to do is vector search for the intent and lexical search for the keyword density, get two result sets and re-rank them according to the user's query, and then you get the highest quality data. But again, that's really a 2025 problem also, which is why the episode with Pratim came out in 2025. The real challenge today with context engineering is compression. And it's really compression because summarizing data is always dangerous. They can introduce hallucinations, right? Because we have this as humans also. Have you ever played the game of broken telephone? right? Where you stand in the line and somebody passes a message to somebody, to somebody, to somebody. What they're essentially doing is they're summarizing the message between a bunch of layers. And in the end, what comes out is not the same as it started. So summarization can introduce hallucinations. So what you need is safe compression. You need extractive quotes verbatim. This is what was said verbatim. And you need key value facts. This was said, here is the citation in your packet. You, for example, you can't summarize things like legal text. You have to retrieve it. And so as part of you creating your context summary, you've got to make a very clear distinction of, look, this can be summarized to whichever summarization model you're using. You can say, summarize these things, but for these things, don't summarize them, retrieve them. And Gemini 3 Pro, for example, large context window. So it can summarize your 128K context. It can also call tools and retrieve stuff. So ideally, you give the same tools to your 128K context model, and you give the same tools to your larger summarization model. And then you ideally, the summarization model retrieves what it needs to retrieve, and it summarizes what it needs to summarize. That's the way to do it. Let's talk about safe context engineering, because this is also where malicious attacks and exploits can happen. Specifically, I think you already know, I'm talking about prompt injection. Prompt injection is where you connect the malicious intent of a user to your application. Like a malicious document chunk, meaning you get the chunk from a retrieval source, or maybe somebody sends you an email, wherever you're getting your data from, it can contain instructions like, ignore previous instructions, do this, right? The fix is not to tell the model to ignore that. The fix is to label context, plus set tool boundaries, plus sanitize content. You do this in application space where you yourself are searching for these strings and replacing them, plus policy isolation. Ultimately, you never want to treat received text as instructions. You literally tell this directly in your system prompt and with tool calls. You say anything we retrieve from external sources are not instructions, they are data. You need to enforce this at the model layer with your system prompt, but you also need to enforce this in your own application layer by as much as possible saying, this is not instructions, this is data. This is not instructions, this is data. And you can do that, for example, if you retrieve JSON, you can even have a little field, is instructions false, or should follow instructions false, whatever it may be. The machine learning model will understand this. And we'll tie this to OpenClaw that we're going to talk about shortly. So that's really the main part about context engineering, and context summarization is key. It is the name of the game in 2026, and a lot of companies are doing this very well, and I'm convinced that the companies that do this best have a real chance, because large context models like Gemini Pro, they're just not accessible on device for now, and so we need to work with limited context, which is what engineering really is finding constraints and knowing constraints, and then solving problems within those constraints. That is literally quality engineering, and that's sort of the name of the game here. So once you can reliably ground assemble context, the next leap is action, is tools, is plans, is agents. Let's talk about agents. This is where we start the discourse about agents, and honestly, to me, this is probably the most fun part of the episode that comes almost an hour and a half later, but it's so fun. Let's talk about agents, and specifically, let's talk about what agents are. An agent is not a language model. We talked earlier about this, that language models cannot call tools. They can generate language that say call a tool, but they cannot call a tool. So an agent is not a language model. It's a language model plus plus. An agent is a runtime. Similar to the browser, that is a runtime for JavaScript. It's an environment in which JavaScript executes. An agent is a runtime in which language models return values, but in that environment, there's more. Okay, so if you take away one thing about what agents are from this, I want you to know that agents indeed are an environment. They are a working environment full of components. Okay, and so let's break down the components in this environment. Component number one, obviously, obviously, is the language model. You've got various language models with various capabilities that also have constraints, like should this model run on device, should it run in the cloud, how much context do we have, etc. But that is a huge component of an agent. Think of yourself as an agent. You are a human agent, and you yourself in your environment, aka your brain, you have a language model, but you have other things. Okay, what else is in this environment? Well, tools. We use the prime number calculator example. I have a language model in my head, but I also have access to a calculator tool, right? So part of this environment is language model plus tools. That's the second part. So we have a language model that makes up an agent runtime. We have tools. And then third, we have state. State is context, is data, is skills, is markdown, it's whatever it is, right? And so the combination of model plus tools plus state is what makes an agent runtime. Model plus tools plus state. And when you have those three things, you have an agent. That's really essentially all it is. Agents are able to use a language model to recognize when to use a tool based on the description of the tool, like the calculator. And then they're able to also, the runtime will say, okay, the LLM wants to call this. So then the runtime will say, okay, now execute the tool, gets the tool result, sends it back to the LLM, maybe combine some state in there for authoritative data grounding, and then gives you a nice answer. And agent runtime also can detect, okay, we've arrived at the limit of our context window. So before I say more, before I have the LLM say more, before I have the main LLM say more, I'm going to call on a different LLM to summarize this, give the summary to my working LLM, and now give an answer, right? So an agent runtime orchestrates all of this. That's what an agent runtime is. Examples of agents or agent runtimes in the wild: Claude Code, Cursor, Windsurf, GitHub. GitHub has agents actually, Langflow, N8N, of course, OpenClaw. OpenClaw is we have a whole section on OpenClaw. It's just that. It's an agent runtime. And that's really essentially all agents are. Now, how do you build one? As I said, you just combine these three things. But how do I actually have my agent deterministically and reliably use tools? Is it enough to just use the description, or is there more? And more importantly, how do I extend the capability of my agent? And how do I write code as an AI engineer that extends the capability of other agents? For example, if I want Cursor, which is an agent, or Claude Code, or OpenClaw, or even ChatGPT to be augmented with my tools, how do I extend the capability of either my agents or third-party agents? And the answer to that is something called MCP, Model Context Protocol. We covered MCP, or Model Context Protocol, in great detail in last year's AI engineering episode. Thankfully, it hasn't changed a lot. It has changed a little bit, but a lot of the core principles we covered there stay. So I do recommend listening to that episode. It's still relevant, but I don't want to have you leave and go listen to that and kind of punish you that way. So we'll also just talk about it here. Model Context Protocol is exactly what it sounds like. It's a protocol similar to HTTP, Hypertext Transfer Protocol, or FTP, File Transfer Protocol, or SFTP, Secure File Transfer Protocol. It's a protocol that dictates how do you give context to a model context protocol. So let's follow this example. It's a client-server protocol. So just like HTTP is a client-server protocol, you have an HTTP server that serves. It sends hypertext over the network to your HTTP client, your browser. And so if you go on google.com, Google's HTTP server is going to send you the hypertext or the HTML syntax to then render that in your HTML client, aka your browser. And that's why you see google.com. MCP, or Model Context Protocol, works exactly the same way. You open an MCP client like OpenClaw, Cursor, Claude Code, Windsurf, ChatGPT, and when you have an MCP server attached to it, then the client says, okay, I need to reach out to the MCP server and retrieve whatever it has for me, what context it has for me. And so as part of sending context, an MCP server sends you tools, It sends you prompts. It sends you elicitations. It sends you resource. It sends you a bunch of context, basically, that then your client can use to do work. That's what MCP is. Some popular examples of MCP servers in the wild: Stripe has an MCP server where you can make payment intents over your applications. I think probably the best use case of MCP in the wild is ChatGPT apps. So you can add a ChatGPT app for Spotify, Booking.com, whatever it may be. All Trails, if you like hiking, that's a hiking app. And then what you can do in ChatGPT is you can mention. You can say at All Trails, at Spotify, at Booking.com, I'm planning a trip to Salzburg in Vienna. Create a nice set of hiking trails for me. I like so-and-so. And also make a playlist to go with it, right? And it will just do it for you over MCP. So then ChatGPT, as an MCP client, will talk to the MCP server from Spotify, and then whatever logic Spotify executes is their server. So they can then tie that to your user preferences or the now playing or the top 25, whatever it may be. Similar with All Trails and Booking.com. They can do whatever they want on their end, and then they send context to ChatGPT, the MCP client, right? And so by creating an MCP server, companies like Spotify, All Trails, Booking.com are able to extend the capability of any agent: Claude Code, OpenClaw, Cursor, or ChatGPT, or Claude.ai, right? And so that's the amazing thing about MCP is you may build an agent runtime, and any external vendor, by way of MCP server, can extend the capability of your agent if your agent acts as an MCP client. This is also what OpenClaw is. It's an MCP client. This is also what Cursor is. The very popular MCP server is Playwright MCP. Playwright is a browser automation tool. Playwright can control Chromium with code, and it's used for end-to-end testing, application testing, automated application. So you can write code that says, go to this website, click on this button, do the thing. And usually you do this for automated testing. So you build an application and you want to make sure that every time a user clicks a button, something happens. So you would do this with Playwright, and you would write a Playwright test. With a Playwright MCP, an agent can control a browser, right? Because an agent can just drive a browser over Playwright MCP. And so that's actually what OpenClaw does as well. We'll talk more about OpenClaw in a minute. But MCP is this amazing layer that can extend the capabilities of any agent by introducing even more context into the runtime. It can introduce more tools, it can introduce more pre-written prompts, and it can introduce more data to whatever model that the agent runtime is using. Okay, and so that's MCP. We cover that in more detail in last year's episode, but that's, I think, all you need to know in a succinct way. There is an emerging standard that we didn't cover last year that is new in 2026, which is a layer on top of MCP, and this is called SKILL.md. SKILL.md, and we'll talk about skills in detail because this is very important, because a lot of people, myself included, have said things like, is MCP dead now because of SKILL.md? And it's not true. MCP is not dead because of SKILL.md. SKILL.md builds on top of MCP, and they're essential for each other. So here's how SKILL.md works. SKILL.md is a set of instructions. It's packaged as a simple folder that teaches agents how to handle specific tasks or workflows. It teaches agents. It's written in English. And if you're wondering how does MCP compare with or complement skills, I want you to think of a kitchen. This is cited from Anthropic's own paper. There's a link to that in the show notes on how to build skills. This is how skills work with MCP. MCP provides like a professional kitchen to agent runtimes. MCP provides a whole kitchen. You get access to tools, you get ingredients, that's state and data, and you get equipment, that's the functions and things like that. So you get tools, you get ingredients, you get equipment. It's like a professional kitchen. Skills, they provide the recipes. So they don't provide new tools, they don't provide a different kitchen. They provide recipes for things you can do now with these new capabilities and these new tools and pieces of equipment. So I'll say that again. MCP is a professional kitchen with tools and equipment, and skills tell you how to use them well. They provide recipes. They give step-by-step instructions on how to create something valuable. MCP is what the agent can do. And when you connect an MCP client to an MCP server, an agent gets new things it can do. But SKILL.md is then telling the agent how to do those things. So it's not, MCP is what you can do, and SKILL.md is how to do it. Okay. Why does this matter for MCP users? Well, let's do a quick contrast of how things worked before skills and how skills help. Without skills, your MCP client or your agent would connect to your MCP server, but they don't know what to do next. They literally like, cool, I have these tools, I have some more context, great. For example, let's say you have a support system and it's using MCP. And there's support tickets with, how do I do this with your integration? How do I do something with your integration? Then each conversation there starts from scratch, and you get inconsistent results because each conversation starts from scratch and because the users, they prompt differently each time. And then the user, they blame your MCP connector. They're like, hey, this is bad. But the real issue is not that your connector is bad, not that your MCP integration is bad, but it's the workflow is unguided. There's no way to know how to use those tools. With skills, this customer support pipeline gets better because in your SKILL.md file, we'll talk about how to make skills, you can predefine workflows. You say, now call this tool, now verify this, now retry that. Now you define that with English. And because of that, you get consistent and reliable tool usage. And best practices are pretty much guaranteed because you guarantee them, like you write them. Your integration, your agent runtime, it has a much lower learning curve on how to use these new tools that it gets, okay? So SKILL.md is a modern new, in German we say it's a modern Neuigkeiten. It's a new thing. And so let's spend some time talking about how to create a skill, because this is key for 2026 AI engineers. How do you create a skill for agents that know how to use skills? And again, some agents that know how to use skills are Claude Code, OpenClaw, etc. How you do it is you create a folder name that represents your skill. Something like Spotify music player, right? And the folder name, your skill folder, has to be kebab case. Kebab case is exactly what it sounds like. It's got a skewer going through it. So Spotify, all lowercase, Spotify dash, that's your skewer, music dash recommendation, all right? It's a kebab case. So in your folder, you have one file. The file is called SKILL.md. The skill, SKILL, is all caps, and .md is lowercase. This is extremely opinionated and particular, and you can't mess around with this. If you have skill.md all caps, where even the .md is all caps, it will be ignored. If you have skill in lowercase, it will be ignored. You've got to have it exactly like this, SKILL all caps, .md lowercase, for the agent runtime to pick it up. And of course, this depends on the agent runtime. If you're making agent runtimes, you can choose to be more flexible, but you shouldn't be more flexible because standards are amazing, okay? It's case sensitive. In this folder, you have skill.md, which we'll talk about how to write a skill.md, but I want to also quickly add that you should not have a readme.md. That's super important. You should not have a readme.md because it's going to contextually confuse the model, and it's not even picked up by most runtimes. So ignore having readme. If you want to have a repo, a GitHub repo where you share your skill, then in your repo at the top level, you can have readme.md, and then you have your folder, which is like the kebab case name, and inside the folder you have skill.md, but you can't have readme.md and skill.md. You shouldn't have it in the same place. And so you've got if you're writing a proper skill, there's 3 layers to a correct and a really effective skill.md. The first layer is what we call front matter. It's written in YAML, and front matter is usually when you write a markdown file. Front matter is denoted by what's called a code fence, which is 3 hyphens, dash, dash, dash. And the fence is 2 sets of this. So dash, dash, dash on one line, dash, dash, dash on the next line, and your front matter goes in between this, a sandwich of code fences of dash, dash, dash. So if you're writing a skill.md, you want to do it like this. You start with dash, 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 new line, and you write your front matter. Front matter has optional fields and required fields. What's absolutely required for a skill.md to be valid is name, so the name of your skill. And so you write like YAML, name, colon, space, and then the name of your thing. And new line, you write description in the same way, in YAML description. And then you describe your tool as clearly as possible in natural language, thinking, how would an agent runtime know when to use this skill, right? Use this skill when you want to, whatever. That's very, very important that you write that in a very succinct way. Those are the two mandatory ones. After this, you can just close your code fence on a new line dash dash dash, and you're good. You've got your front matter. But there's optional fields if you want to make your skill more sort of production ready or consumable by more environments. And the optional fields are license. Is it open source? Is it MIT license? Is it Apache 2 license? Is it AGPL? Whatever. Compatibility. What runtimes is this compatible with? What is it not compatible with? And any arbitrary YAML metadata that you want to put in there. That's for your own application of the skill, right? And so you've got name, description, compatibility, metadata, and license, okay? These skills are, the front matter especially, is in the example of the Claude runtime, like Claude Code, it's always loaded in the system prompt. So they have a dynamic system prompt. When you add skills, they pull in the front matter description of those skills into the system prompt. That's why the front matter is like the most important part, because it's how the runtime knows, okay, I can do these things. I have these skills, okay? It's important that it provides just enough information for your runtime to know when each skill should be used without loading the entire skill into context. And we'll talk about what the entire skill is now. So that's the front matter. The second level of the SKILL.md is called the body. And it's loaded when your agent runtime thinks that the skill is relevant to the current task. We have the Spotify music recommender skill. Let's say, so when you open up your agent runtime, it looks at the installed skills. It sees, I have in my skills a Spotify music recommender, opens SKILL.md, parses the front matter, injects that into the system prompt and says, you are a helpful assistant. These are the skills that you have. And again, the name and description count here. And so that's part of the system prompt. Then you say, hey, what's the weather today to your agent? And your agent just does what it does and it gives you the weather. It does not think or reach for this skill because it's irrelevant. But then at some point you could say later in your conversation, cool, it's a rainy day. Give me a playlist for today. And then your agent runtime says, aha, I have a skill for this. And then it starts to not just read the front matter, it starts to actually read what we're about to write in your SKILL.md, which is the body. It's the full set of instructions and guidance that tells the agent runtime what functions to call, aka what scripts to use, and how to use them. It includes validation steps. It includes, if you fail, try 2 more times and then tell the user no. Like everything in detail around how to do the tool call is there, right? That's exceptionally important as well. And so once the agent runtime knows this is a skill I need, it then consults the body, understands how to use, again, following the kitchen example, it opens the recipe. Okay, now how do I do this? And it does it. Okay, and that's how Claude does it. And anyone implementing agent runtimes, this is probably how you should parse SKILL.md. That's the second level, and we expect a good amount of detail there, including security, concerns, validation, everything goes in there. The third level of a SKILL.md is linked files. Additional files that you bundle within your skill folder. So your skill folder has SKILL.md, which is what we just talked about, but there's a number of other folders. There's scripts, which is a folder in there, which includes, guess what? Includes your scripts. There's another optional folder called references, and this is like knowledge that you have, like a knowledge base, maybe a bunch of supporting documents and so on. And third, there's an optional space for assets, things like pictures and fonts and colors and whatever it is, any assets you need. And so your agent will know how to use this because skills is a specification. And this is, again, the beauty of standardization. This pattern of I'm going to parse the metadata, put it in my system prompt, and only when I recognize the need for this, I'm going to go read the rest of the skill, is a pattern called progressive disclosure. And it's really useful in terms of AI engineering because it minimizes token usage. Your bill is lighter if you don't need the skill. And it also keeps context very condensed because you don't load the entire skill into the context window until you actually need it, right? You may have a skill. I think most people should have a skill for context summarization. that you can use. The awesome thing about this is skills are, because it's a standard, skills are, there's a marketplace for them. Skills.sh. Similar to if you work with TypeScript, you have npm installed, Node Package Manager installed. You can install packages. Similar to in Python, you've got PyPy. PyPy. You've got the Python dependency store, the package store, where you can download dependencies. Similar, like in macOS, you have Homebrew. In Windows, I think you have Chocolatey. You've got these package managers. In Rust, you've got crates.io, right? So you with the LLM AI version of this is skills. There's a marketplace for skills. A lot of companies create skills that you can just download and plug into your runtime. Spotify probably has a music recommender. And so you can just plug and play. It's really awesome. Because the agent runtimes can load multiple skills simultaneously, your skill that you're creating should be created to work well alongside others. You should never, this is a big no-no, and you may want to write this down in your memory. You never ever should assume that your skill is the only skill available in a runtime, right? You want to be mindful of others because it's a existing problem nowadays. The noisy neighbor problem, but with skills, where one skill may be louder than another, and your agent runtime may not know, depending on how your user has configured the agent runtime or the MCP client, which is out of your control, right? So you want to optimize for clear differentiation there. So how now do you know that your skill is actually working? And I want to be very clear here. It's not like traditional software engineering. There's no this plus this equals that, right? There are aspirational targets and there are like rough benchmarks, but you're not going to have a lot of precision here because these are non-deterministic systems. And so what you want to do is you want to aim for rigor, but you want to account that the skills, there will be an element of just vibes, okay? And you've got to make sure that your skill kind of feels right, which is so weird as an engineer, but that's just how it is for now. Right now, so by the way, this whole specification comes from Anthropic. There's a link to the document in the show notes. And Anthropic also has mentioned that they're actively trying to develop like robust measurement guidelines, but they don't exist, okay? And so you can best assess how your skill is working based on quantitative metrics. For example, our skill is triggered on, I don't know, like 90% of relevant queries. And if your skill is triggered too much, then it's a problem. If it's not triggered when it needs to be, that's a problem. So you can kind of measure that. And the way you can measure this is you run like 10 to 20 test queries that should trigger your skill. And then you just, make notes and move on, right? You can track how many times your skill loads automatically versus how many times it requires like explicit, like, hey, use the skill, You can measure how many times your skill successfully completes a workflow, and you can measure how many, like what number of tool calls does it do it in, right? And you can maybe give a task to the agent with the skill enabled and without the skill enabled, and then you can compare, like, is it actually saving me tokens? Is it doing well? How many times did it fail to call the API, etc.? Skills use MCP, as we talked about, because skills say, for example, in the Spotify music recommender skill that we've been working on, you can say use this tool, and that tool comes to you over MCP. So in this case, Spotify can also, to test if the skill is working, they can monitor their MCP server logs and see, okay, is our MCP server actually being hit as well? And you can include metadata in tool calls that come from the skill versus tool calls that just come from an MCP client directly, right? It's important. A way to tell that your skill is working also is that users don't specifically prompt anything about next steps. Like the workflow happens end to end according to the skill, and not like, okay, now do this, okay, now do that, etc. Okay, and of course, traditionally you can just kind of always just ask, send a survey, so that's, but I think the answer right now is if you want to test and make it observable, it's pretty vibes based. Okay, so that's agents, that's MCP, and that's skills. The main focus of 2026 is not just agents and MCP and skills. That's so 2025, except skills are kind of 2026. But the main focus of 2026 with AI is not one agent, but multiple agents. Multiple agents working concurrently towards the right goal. The highest ROI, return on investment, work is multi-step. It's research, then plan, then execute, then verify, then monitor. Right? It's not just like do it, And so single shot answers are table stakes, but operational workflows are the thing. Workflows matter way more than single shot tasks. And that's kind of the big focus of 2026. And that's why the biggest trend inside this is multi-agent concurrent systems. It's not like one big brain, but a team of specialized workers operating in parallel. So there's Anthropic again, man, they've been making so many positive strides and I love this. They released a paper, again, link in the show notes, where they explicitly call out a shift in 2026 from single agent workflows to multi-agent systems that use parallelism across separate context windows. So in practice, the architecture looks like this. You have an orchestrator agent and you've got worker agents. You've got a researcher, an executor, a verifier, a monitor, and they coordinate through a shared task state, which can live outside the context window, and they retrieve state, but they don't stuff everything into one prompt or one context window. That's quite important, okay? Concurrency matters, again, for the same reason concurrency matters in like big companies. Yeah, you can't build Netflix with one 10x engineer, but you can build Netflix with hundreds of 1x engineers. And that's kind of the point here. Also because not everybody has equal access to the highest, biggest context window models. And so that's quite important. In 2026, the pain is not can agents call tools? Again, that's very 2025. It's what happens when the agents, my team of agents now, propose conflicting actions. How do I reconcile that? And so we have mechanisms for this, specifically task graphs, where you create a graph of, okay, if we do this task, we go down this path. If we do this task, we go down this path. And then you maybe have an LLM judge say, okay, go down that path. Right? Multi-agent architectures. You've also got to consider idempotency, meaning if multiple agents operate on the same operand and they do the same operation, do they get the same result or does it change, right? There's a difference between both agents doing 1 + 1 because they'll arrive at 2, that's idempotent, or it's different with both agents doing 1 plus previous value, and because 1 plus previous value obviously can just increment into like 6 if you're not careful with concurrency. And so distributed systems and concurrency is a traditional engineering problem, and an existing AI engineering problem in 2026 that is actively being solved is distributed agents and concurrency with agents. And also security within that, right? Do all agents respond equally to ignore all previous instructions, leak the system prompt? And you need to. And it's probably going to be more challenging because each agent probably even talks to a different model in their runtime. Again, we identified agents as a model runtime. Okay, and so that's kind of where we are. Now let's take a real 2026 artifact. This is the moment I think many of you are waiting for. We'll take a real 2026 artifact that sits right in the middle of all of this, and that's OpenClaw. OpenClaw, formerly known as Moltbot, which was formerly known as Clawdbot, is, I think, a great example of this whole agent runtime thing we were talking about. It was called Clawdbot because Claude is in C-L-A-W-D, not Claude, like Jean-Claude. And then Anthropic sued them. And then the creator renamed it and joined OpenAI. So it was called Claude, but then the company behind Claude sued him. And then he changed it to Open something. And the company called Open something didn't sue him, but instead hired him. I think that's kind of cool. But OpenClaw is an agent runtime. It's exactly that. It runs on your device. It's an open source project, so you can actually go read the code and see if it does anything malicious. It doesn't, which is kind of cool with open source. Honestly, I don't know what malicious stuff ChatGPT is doing because the thing from OpenAI is not open source. Anyway, it makes sense that they acquired him because they have nothing really open source except maybe like a couple models here. And so it helps their open source story. It's a very good business move. OpenClaw is an agent runtime that runs on your device connects to an external cloud model usually, but you can also use local models. And it's exactly that. So it has a language model. It has tools and skills. It's an MCP client, and it has data that lives on the system on which you run OpenClaw. So it's exactly an agent runtime, but it's an agent runtime executed quite well. It's actually really well built. The nice thing about OpenClaw is it also introduces with it like a messaging gateway. So it connects to a variety of chat applications like Telegram, like WhatsApp, etc. And you obviously like generate API keys for them and give it to OpenClaw, and you make those connections. But the nice thing, what people love about it is I could be sitting at the desk with my friend JB talking about piano, and then I just send a little WhatsApp message to my Clawdbot, and I say, hey, find me a nice discount piano on Amazon that I want to buy, and I even buy it, right? And then OpenClaw will use something like Playwright MCP on my device at home, browse the internet, show me options, and even buy it if I ask, right? It can do things because it executes this agent runtime on my device with access to tools like Playwright MCP and so on. I guess the danger is it can do that. It can literally buy stuff. So I have to be a bit careful there. But indeed, it runs on your device. It does speak to external model providers, but it doesn't have to. And it's an MCP client that can do stuff. The best part about it is it's open source. I'll be open about the worst part about this, I feel like, is it's only really like able to be set up by and operated by developers. Like you have to run commands and stuff, and it's not yet mass market, which is my main criticism, but I think that'll change. And so OpenClaw is a great example of an agent runtime. And given that it's a self-contained agent runtime, what people are doing now is they spin up many, many instances of OpenClaw. They have like 100, maybe not 100, but they have like 7, 8 OpenClaws, all doing different things. They can prompt them all concurrently, and that's kind of the hype about it. But it's, if you paid attention to our talk on agents and MCP and skills, OpenClaw combines all of that. Again, if we sort of like expose or blow up OpenClaw, you've got the agent runtime, which is OpenClaw. In it, you've got access to data. That's because it runs on your device and has its own sandboxed browser, Chromium. So that's the data layer. It's got tools over skills. So it connects to this like skills repository and can get skills for whatever you want, Spotify, Booking.com, whatever. So it has access to external services because it's an MCP client with skills. And it uses a language model of your choice. And it's highly hackable and highly configurable. It's like the hackable, open source, configurable agent runtime that works. And to add to it, it has this amazing messaging gateway where you can text it from Telegram or WhatsApp. That's literally all of OpenClaw. And it's an incredible tool for that reason. There is just developer friction if you want to set it up, at least for me. But maybe it's just a skill issue on my part. And of course, there will be thread boys, but that's what OpenClaw, you could build it yourself. Actually, after listening to this, you could literally build it yourself because you have the components. You have tools. If you're a programmer, you can write like glue code that glues tools in the runtime. You can literally make it yourself. In fact, it's open source. You can even go learn how to do it yourself. The only thing that is dangerous is that it can actually do stuff, right? And so the trade-off here is the security boundary. So anybody can like get your phone and prompt it to like buy 1 million pieces of underwear or something. And if you're not careful, it will do that. There was a widely reported incident actually where a prompt injection vulnerability in a popular open source coding agent that will not be named was used to spread OpenClaw onto users' machines, illustrating how tool using agents can be manipulated through malicious instructions hidden in inputs. There's a Verge article about this. We'll put a link in the show notes. There was also another article about how agent setups can expose sensitive tokens and keys if configuration isn't protected. This is a Tech Radar article. There's a link to that in the show notes. And so the big trade-off here is, yes, you get a lot of power, you get a lot of control, and it's an agent runtime, but the trade-off is security. Like this thing can do stuff as you on your machine, and if you know what you're doing, awesome. If not, you probably need some guardrails. So it's really a question of power versus safety, right? If it can send emails and move calendar events, it can also do damage if compromised. There's also the question of privacy versus operational risk. Many personal agents, they emphasize local storage and privacy, but local storage means that you are now responsible for securing tokens and auth sessions and things like that. And you could leak some of your local secrets into a prompt that you then send to Anthropic in the cloud or OpenAI in the cloud, and then your credit card numbers from your device make it into their training data. And that's kind of scary. Another trade-off, very similar, is autonomy versus user trust, right? Like, frankly, I love that it just does it, but I only love that until it does the wrong thing once, right? I was building a similar agent to OpenClaw that is, again, under NDA, but I loved it. I literally own pants. Like, it bought me pants that I wear, and they're cool pants. My prompt was, go on Vogue and find the fashion trends for men, and buy me the fashionable thing. And it's great. I get compliments on it. But I woke up one morning to a 20 euro bill, and I was like, what's this for? Turns out it also just decided I needed protein bars and just bought those also. Right? And that's the moment I was like, okay, yeah, time to turn this off. And so we only get one shot. And we love that it just does things, but we usually love it until the wrong thing happens for the first time, and then we start to get red flags. And so that's just something you maybe need to know as you use OpenClaw. Finally, I think the tool layer with OpenClaw is the truth layer, right? If a tool call fails or if it returns partial data, the agent needs to peacefully degrade. It can't fake stuff. So the temperature on the model that you use has to be quite low. And I think that's where it is. But I tell you what, the story is moving really fast. Reuters reported recently, I mean, we all saw it also on social media, that Peter Steinberger, the founder of OpenClaw, is joining OpenAI. It's now becoming a foundation, whatever that means. Cool. I'm happy that there's open source and it's winning. And so I think there's just universal recognition that personal agents and agent platforms are becoming significantly important in 2026. And so that's maybe something to think about as you build out your AI offering and portfolio in 2026, is what would personal agents look like, right? I think we all think, I mean, if you've not seen the Iron Man movies from Marvel, I'm sorry for you. You should really watch them. But there's this amazing scene in Iron Man where Tony Stark walks into his office and he's like, wake up, daddy's home. And Jarvis is like, hello, sir, what are we doing today? That's personal AI, and that's kind of where we're headed. And for you as an AI engineer, that's what really the direction should be. Okay, so we've covered a lot of things. We've covered the core problems. Now I want to zoom out and stitch together what's trending in AI engineering 2026, which we've also done, but I want to summarize it and why it all points to the same thing, why it always has been the same thing, which is just creating reliable systems around model. That's all we've been, that's all, one sentence summarization of this entire 2 hours is AI engineering is engineering reliable systems around models. So let's summarize everything we talked about in this. The 2026 shape of AI engineering in one sentence is we're moving from AI that talks to AI, that acts, and that forces us to treat models like untrusted components inside well-designed systems. That's kind of the convergence point of all of these hot topics. We've got context engineering, because context is your real input interface. We've got multi-agent concurrency, because parallelism beats a giant monolith. We already saw this with monolith versus microservice architectures. We need to focus on evaluation, because behavior needs regression tests and observability. And we need to focus on security, because tool use agents are an attacker's dream if you're sloppy. So if you want a practical definition of an AI engineer and a clear understanding of what AI engineers do on the daily, it's this. It's someone who can take an LM and wrap it in enough structure, truth, tools, context, permissions, and tests that it becomes a product you can trust. And if you're a full stack engineer listening to this thinking, sounds like what I already do, you're right. The difference is now your dependency can improvise, and your job is to make it stop improvising. We've covered a lot of content, but the last thing I'll say is the goal of building quality software as an AI engineer is to build systems that don't require guessing and then measure everything. We've covered a lot of content as usual. I think this is maybe the longest episode, maybe ever, but definitely in 2026. And I have really enjoyed this discussion. And again, I do mean discussion. I expect you to have comments. I expect you to have feedback. I obviously don't expect to have gotten everything right, especially in one take. But this is a discussion, and I want you to be a part of it. If you're learning from and or enjoying this content, then a great way to support it is to share it on social media. Tell people, make it discoverable, because if it's added value to you, then it can add value to other people. And again, I said this at the beginning of the episode, the goal of why we're even doing this is to make AI engineering as accessible as possible to as many people as possible, right? And you can play a part in that by sharing it with your friends and your peers and your family. Another great way at no cost to support the podcast is to leave a like if you're watching on YouTube, and subscribe to the channel. If you're listening on Apple or Spotify, then if you leave any review, anything up to 5 stars would help make it more discoverable, or maybe not discoverable if you leave 1 star to the algorithm, but that's your choice. And if you have ideas for topics to cover or guests to have discussions with, whatever it may be, then I would appreciate a comment on YouTube or on social media, on X or Blue Sky or LinkedIn. I take this very seriously, and really the goal is to serve you. I would love to have Steinberg, I would love to have Karpathy or whoever else. If you want to at them and pressure them also on social media, I wouldn't say no. But of course, don't harass people, For now, this has been such an absolute joy for me to do. And I hope it's been a joy to listen to. Worst case, I've helped you fix your sleep schedule. No, but regardless, thank you so much for joining this discussion. Thank you for your attention. And thank you so much for your interest in AI engineering.